Welcome. We are going to be going over the review for the hand test for the polynomial functions test. And the very first section is to write a possible equation for each polynomial function that is described. And there could be a myriad of equations. We're just looking for one of them. And oftentimes a sketch does help. Okay, for the first one, I'm going to do a sketch quickly. We have zeros at -2, 0, and 5. And then we have a double zero at 3. And it's a fifth degree polynomial function. And so it could be this shape here. And as you know, this would be a fifth degree polynomial function with a leading coefficient that's positive. In this case, it could also have a leading coefficient that's negative, and it could look something like that. And either one, what we've got is all of our factors, and we're leaving it in factored form. And there you go. And if we wanted to, we could have plus or minus. So going on to the next problem, we've got a cubic function. In this case, it specifically says a leading coefficient is positive, and we've got zeros at -5 and 3, and this 0 at 3 is a double one. So since it's a positive leading coefficient, it is going to be starting from down in the left, and there we have it. And so our equation could look like this, and we could have any positive constant as a leading coefficient if we wanted. And the next one, we've got a quartic function. Specifically, we've got a leading coefficient that's negative. So we've got a double zero at -3 and single zeros at 1 and 5. And since quartic functions will have this general shape or this general shape, and since the leading coefficient is negative, it has to look like this one. And the double zero is here, so we'll be coming up and bouncing back from the x-axis and then zipping through both of those zeros. So our function would look like this. There you go. And now that gives us, as you can see, we would have a leading coefficient here that would be x squared times x, which is x to the fourth, which is positive. So we'll specifically have to make sure that we've got a negative function there. Okay, the next one, we're given a sign chart. And a sketch will help us a lot here. So we know that the y-axis would be coming somewhere through here, if you care about that. And since the function is positive on both sides of this -2, that means that we've got a double zero, at least a double zero at -2. And then we've got from the 0 at 1, we've got to have a negative value for the function in between 1 and 4, and then it's going to remain positive. So we can say that this could be a quartic with a leading coefficient that's positive, and there we have that equation. And once again, we know that the leading coefficient has to be positive. Okay, our next section is finding zeros and then expressing the polynomial function in factored form, and I specifically am asking for integer coefficients. So if we've got -3 as a 0, that means that one factor is going to be x plus 3. So let's take the polynomial function and let's divide by x plus 3. And since this x plus 3 is a factor, we should have a remainder of 0. And there we do. Now, this array of values here represents the quadratic trinomial 5x squared minus 7x plus 2. And you can depend now on your years of experience with the graphing quadratic function, or, excuse me, for factoring quadratic functions. We'll have to have 5x and x, and to get 2, we'll either have to have a 2 and a 1 in this order, or a 1 and a 2. And if you look at it a second time, we're going to have 5x and 2, x and 1. The signs have to be the same for multiplication to get a positive, and so we'll have to have them both be negative. And you can see that both of these are linear factors, and we can't factor those anymore with remaining to still have integer coefficients. So we know that these two are the last factors, and then the zeros would be 2/5 and 1. So here we have the rest of the zeros, and then expressing it in factored form, there we'd have it. Okay, the next one, since we have zeros of -9 and 2, then for sure we're going to have factors of x plus 9 and x minus 2. So let's divide to confirm that we do have those factors, and then to make it easier to continue factoring. And I just noticed here I've got that extra little digit that I'll get rid of. Okay, let's divide by x plus 9 first. Okay, we get a remainder of 0, and then this stands for x to the third minus 2x squared plus 25x minus 50. Let's take that and divide by x minus 2. And we've confirmed that both of these are factors. And what we have left over, these digits represent x squared plus 25. And since we have the sum of two squares, if we can't factor it and still have integer coefficients, so that means this is a prime factor. It's quadratic. So that is the third factor. And so we've got the factored form. Oops, this is g of x. And all that's left to do is to find the two zeros that come from this quadratic factor. And many of you have jumped into solving this and using the quadratic formula, and I think you'll be happier finding the zeros if you just do two steps of subtracting 25 and then taking the square root of both sides, of course remembering positive and negative roots. And there you have it. Those would be the last two zeros, 5i and negative 5i. Okay, the next one here is we've got zeros of -1 and 7. So we have factors of x plus 1 and x minus 7. And let's take our fourth degree polynomial function, and let's first divide it by x plus 1. There we go. We've got a remainder of 0. Now this is x to the third minus 11x squared plus 57x minus 203. And let's divide that by x minus 7. Hmm. Okay, back to finishing this problem. We have a positive 29 and positive 203. There we go. We've got a remainder of 0. And here we're left with x squared plus 4x plus 29. And in your experience from factoring polynomials or factoring quadratics, you can see that that would be the only possibility for getting x squared at a positive 29, and it will not give us negative 4x as a middle term. So it's not factorable with integer coefficients. So that is our last factor. And now we can use the quadratic formula to find the two factors that go with this quadratic. So x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. So 4 equals the square root of 16 minus 116 all over 2. So x equals 4 plus or minus the square root of negative 100 all over 2. So x equals 4 plus or minus 10i all over 2, which reduces to 2 plus 5i and 2 minus 5i. There you go. I filled up the time for this. I'm going to shut this off and we'll continue and we'll finish the review. Thank you.